Welcome to Python Time Series, AR and MA Models. In this lesson, we will explore how to use Python to work with time series data. We will focus on two foundational forecasting models. Autoregressive open parenthesis R close parenthesis models. Moving average open parenthesis mar close parenthesis models. By the end, you will know how to load real data, build, and interpret basic AR and MA models. Let us get started. Think about where you see numbers changing over time in real life, sales, temperature, or even YouTube views. Let us set up our Python tools. We will use pandas for data, matplotlib for charts, and turn off any warnings. This comment reminds us what we are doing. We turn off warning messages to keep things clear. Pandas lets us load and work with data tables. Matplotlib is Python's most popular library for making plots. Try running this cell. If you make a typo, Python will usually point it out. Why use autoregressive and moving average models? Autoregressive open parenthesis R close parenthesis and moving average open parenthesis mar close parenthesis models are basic building blocks in time series forecasting. They help us make sense of trends and random changes in data that arrives in order over time. Let us load a real dataset next. You encounter time series whenever the order of the data matters, for example, daily sales. Now we will download a real-world dataset. This one tracks the monthly number of airline passengers. Let us check its shape and preview the first 5 rows. This comment tells us the dataset about to be loaded. We load the data from a web link using pandas. Printing the shape shows us the number of rows and columns. The .head method will show the first few rows to check how the data looks. Practice. Try changing .head to .tail and see what happens. Let us make a simple line plot of passenger numbers over time. Visualizing data is a great first step before any analysis. This comment describes our goal. We set the plot size for readability. Plotting the number of passengers over all months. Adding a chart title helps us remember what we are seeing. This is the label for the horizontal axis. This is the label for the vertical axis. This command shows our plot. What patterns or trends do you notice? What is an autoregressive open parenthesis R close parenthesis model? An AR model uses past values of the data to predict future values. Think of it like guessing tomorrow's weather based on the last few days. Can you think of a situation where only recent history matters most? Let us create columns showing each value's past history. These are called lagged features in time series. We will look at a 1-month and 2-month lag. This comment explains we are making lagged values. We make a column that holds last month's passenger count. This does the same, but for 2 months ago. Let us peek at the new columns along with the original. Do you notice any missing values at the top? That is normal when lagging data. Now let us try a very basic autoregressive model called AR order 1. This means we predict each value purely from the value before it. Comment says we will use a simple AR order 1 model. Here, our best guess for this month is just last month's value. Let us compare original and predicted values side by side for the first 10 rows. Notice the predictions only start where past data exists. What is a moving average open parenthesis mar close parenthesis model? A moving average model predicts future values by looking at past errors. Errors are just the differences between what the model expected and what really happened. It is like averaging out the surprise from recent events. Sometimes, paying attention to mistakes can make our predictions stronger. Let us measure the error of our AR model. The error is the actual value minus the predicted value. Comment explains we are about to make an error column. Subtract the prediction from the real number to get the error. Show the errors along with the actual and predicted values. Spot where the errors are largest. Would you trust our simple model everywhere? Now let us try a very simple moving average model of order 1. We base the next prediction on last month plus last month's error. The comment states this cell is for a simple MA order 1 model. Prediction is last month's number plus last month's error. Compare predicted and actual values for the first 10 entries. Does adding the error make us closer or farther from the real values? Fitting AR and MA models with Statsmodels. Python Statsmodels library makes fitting better AR or MA models easy. Let us use some real modeling functions. Statsmodels is a powerful library for statistics and time series analysis. Let us fit a real AR model now. We import Autoreg from Statsmodels. Setting lags equal to 1 gives us the basic AR order 1 model. We print the parameters to see what the model learned. This line reminds us what the code is about to do. Importing the Autoreg class for autoregressive models. Fit an AR model of order 1 to our passenger data. Print the result, which tells us what multiplier and offset the model picked. Every model in Statsmodels has a .params property to show what it found. Now let us fit a real MA model. We make an ARMA model with order 0 for AR, 0 for differencing, and 1 for MA. Let us see the parameters this model learns. This comment lets us know we are fitting a moving average model. Import the ARMA class since it handles MA models too. Set up and fit a model with only a moving average part. Print what parameters the MA model discovered. Try changing the order to 002 to add a longer MA window. Let us visualize how well our AR model tracks reality. We plot both the actual values and the AR model's predictions. Adding a new column for predictions using our Statsmodels AR fit. Set the figure size to keep the plot readable. Plot the actual data so we can compare it. Plot predictions from the AR model. Add a legend to tell the lines apart. Title adds context above the chart. Display the finished plot. Where do the lines follow each other and where do they differ? Now we will do the same plot for the MA model predictions. Let us see how this simple MA fits the real passenger data. Add a column for MA predictions from our Statsmodels fit. Set up the plot size again. Show the original passenger numbers. Show the predictions from the MA model. Legend helps us see which line is which. Title explains what the plot shows. Show the plot. Try turning the legend off by removing the .legend line and see what happens. What about ARMA models? ARMA models combine both AR and MA ideas. They use past values and past errors. ARMA is great when your data has both trends and unpredictable changes. Let us build one. ARMA stands for Autoregressive Moving Average. Let us fit a simple ARMA model to our data. Order 1 means 1 lag of AR and 1 lag of MA. This is sometimes the right balance for real-time series. This comment states we will make an ARMA model. Import ARMA since ARMA is a special case of ARMA. Fit an ARMA with 1 AR lag and 1 MA lag. Print the estimated parameters for AR and MA. Try changing order to 202 for more lags if you are curious. Now let us see how well the ARMA model fits the real-world data. We will plot real values and predictions together. Generate ARMA predictions and add to our data frame. Get the plot area ready. Plot the actual airline passenger counts. Show the ARMA predictions line. Bring up the legend to help compare. Add a title above the graph. Display the plot window. Which model seems to fit the data best so far? Train/test split, testing model predictions. To see how a model performs, we need to test on new data. Let us split our time series into training and testing sets. Testing on new data is key for honest forecasting. Let us set aside the last year of data for testing. The rest is for training the models. State that we are splitting data in this cell. Find the split point by subtracting 12 months from the end. Use all data before the split as training data. Use the last 12 data points for testing. Print sizes to check the split happened as planned. Splitting this way mimics the real-world challenge, predicting the future. Let us train ARMA on the training set only. We forecast the next 12 points and compare to the actual test data. Plot shows all three: training, test, and forecast. Comment says train/test prediction with ARMA. Fit the ARMA using only the training part. Forecast for 12 months ahead. Set plot size so we can see the details. Plot training data for reference. Plot test data, the true future numbers. Plot the forecast made by our model. Legend so we know which is which. Add a title for clarity. Show the completed plot. See how the forecast behaves as we move into unseen data. Let us measure how close the prediction is to reality. We use something called mean squared error, smaller is better. Comment says we are scoring forecast accuracy. Import the metric we need from scikit-learn. Compute mean squared error on real versus predicted. Print out the results so we can see our model score. Can you improve the score by changing model order? Mini project, forecast shampoo sales. Practice time. Let us forecast the next few months of shampoo sales using ARMA. We will load a similar retail sales dataset and repeat what we have learned. Working with multiple datasets makes your skills stronger. First, let us load and plot shampoo sales. You might see patterns look similar to airline passengers, or not. This comment shows we are loading shampoo sales. Read the CSV from a web link. Pick a good plot size. Chart the sales data to spot trends. Give the plot a helpful title. Label the x-axis with months. Label the y-axis with sales. Show the chart so we can analyze. What would you expect sales to do in the next few months? Let us fit an ARMA model and guess the next 6 sales months. Forecasting can help a business prepare inventory. The code states it is for ARMA forecasting. Import ARMA once more. Fit our ARMA model to the sales data. Ask the model to look 6 months into the future. Show the heading for the output. Display the numbers predicted for the next months. Try forecasting for 12 months instead. What do you notice about faraway predictions? Recap, what did we learn? Loaded real-world time series data. Built basic AR and MA models by hand and with Statsmodels. Compared AR, MA, and ARMA predictions and plots. Checked forecasting on new data using train/test split. Well done! You now have the tools to continue time series forecasting in Python. Which step was hardest for you? Try reviewing that part with your own comments added. Challenge, your turn. Try a new AR or MA model order on the airline data. Plot the predictions and compare errors. Load a different time series dataset and apply ARMA. Want more? Like and subscribe for new lessons every week. Keep practicing and share your best plot with someone. If you found this lesson helpful, please subscribe and check out our channel for more.